Alrighty, so today we're going to go ahead and talk about dilations. You're going to want to make sure you have a calculator with you because we're going to do some multiplications. Maybe. There you go. Alright, so the idea today is to determine a scale factor, and we're going to go ahead and graph some dilation images. So first things first, what is this dilation? A dilation is a transformation, which is something that's been changed. So we are going to physically change whatever we're working with, whose pre-image and image are similar. So what that means is a pre-image is the shape that you're given in the beginning to work with, and then your image is what it's been changed to. So pre-image is before, image is after. So with dilations, they're going to be the same shape, just different sizes. So same shape. So they should look, if you're given a triangle, you should end with a triangle. If you're given a rectangle, you should end with a rectangle. The only difference is they're going to end up either being bigger or smaller. Okay, so every dilation has a center and a scale factor. The scale factor describes the size change from the original or the pre-image to the image. It's considered an enlargement, which means it's bigger. If it's bigger than 1, and it's considered a reduction or a shrink if the scale factor is between 1 and 0. Now remember, some fractions are bigger than 1. So in your homework, hint, 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 you're going to want to take a look at some of the fractions you're given and actually make sure they're between 0 and 1, because not all fractions are less than 1. Alright, so let's take a look at this first shape here, the red and the blue. This one's considered an enlargement. The reason being is, if you notice, my original shape is red. I have A, I have B, I have C, and I have D. My changed shape is the blue one. It's got this A prime. So I know it looks like A apostrophe, and you're like, how do you even say that? That means A prime. A prime, then we've got B prime is over here, C prime is way up here, and D prime's down over here. So again, if it's been changed, it'll have that prime notation. So that helps us indicate which is our first or our pre-image and which is our second or our image. So in this first case, again, we went from small to big, so it's an enlargement. And it's telling me my scale factor was a factor of 2. Well, how can you figure that out? You take a look, 2 times something got me 4. Something else to note. Only multiplication today. So 2 times something got me 4. 2 times what gives me 4? 2. So this was an enlargement by a scale factor of 2. Let's take a look at this. Back up a second. Notice how my A and my A prime didn't change. They're in the exact same spot. That's because my center of dilation was focused at that specific part of A. So everything else moved but A. This one, which is the original, the purple or the green. Good, the purple. The reason being is the purple doesn't have those prime notations, or it doesn't have those apostrophes with them. So this one, if you notice, is not centered at a specific vertex. It's actually centered in the middle. So in this case, it's centered at that C point. When we go ahead and do our dilations for homework and in a couple slides, most of these are going to be centered at 0, 0, so you don't really have to worry about that. It'll give you just your dilation stuff for you. Also, if you notice, from our purple to green, our, in this case, trapezoid, got smaller. So he was a reduction, he shrunk. And you're wondering where this 1/4 came from. Well, something times 8 So 8 times my favorite letter. Oh, what is my favorite letter today? Let's go with W. So 8 times something gave me 2. Because I went from my big green down, I went from my big purple down to the little green. Well, let's figure out what that factor was. Divide both sides by 8. W is equal to 1 over 4. Because remember, I can take 2 divided by 2 and 8 divided by 2, which gives me 4, or 1/4. So that's how we got that scale factor of 1/4. Alright, so we're going to go ahead and find the scale factor here. So the blue triangle is a dilation image of the red triangle. Okay, what does that mean? That means that the red is the pre-image and the blue is the image. Now remember, we said pre-image is the thing we started with, so the red thing is our first piece. The blue thing is what we changed it into. So in this case, we're centered at X. I can see that I'm lying on the exact same spot as I was before. Excuse me. So we're trying to figure out how did we get this whole side. So when we do our, trying to find our scale factor, we're going to have the new over the old. So I told you, if we pause for a second, go back. Where's my, there it is. We're going to go back a slide. I ended up multiplying to start with. That's how I set up my equation. But then I ended up dividing these out to determine that scale factor. So I'm going to have the new divided by the old, or let's use our math terminology, our image divided by our pre-image. So if we take a look, our image is not just 8, because 8 is only from t to t prime. I want all the way from x prime to t prime. So that's actually 8 plus 4, which gives me 12. And then I take that divided by the old, or the pre-image, and that gives me a factor of 3. You can also think to yourself, if you know that our original was 4, I'm just making sure W is not in here. No. 4 times my favorite letter of W gives me that 12. So 4 times what will give me 12? 3. So that's essentially 2 different ways to describe the same problem. Cool. All right. The blue quadrilateral is a dilation of the red quadrilateral. Describe the dilation. So, excuse me. Which ones are original and which ones are changed? Which is the image, which is the pre-image? Yeah, the red one is my pre-image. And that means my blue one has to be my image. Okay, so let's talk about our center. When we deal with graphing on a coordinate grid, our center is typically just going to be at the origin. So here it is, it's at 0, 0. The reason I know that is because it's not centered at a specific point. All of the points ended up changing together, and when we graph them on our grids, they're going to be changed to, they're going to be centered at the origin or 0, 0. Alright, so we need to figure out the scale factor. Now, in order to figure out scale factor, I need to figure out length. And I want to think about length the smartest way possible. If I take a look at any of my sides, can I just count my boxes? Not really on any of these 3, because I don't have nice straight lines. Remember, I have to go the whole box length. I can't go part of it. So if you notice, KL and K prime L prime are both straight lines, so I can actually figure out how many blocks we used. Aha, tricky, tricky. So KL is 1, 2, 3, 4 blocks. In my image of K prime L prime is only 2. So that means that 4 times my favorite letter W, because I don't know what it is equal to 2. So divide both sides by 4 to figure out that favorite W. I get 1 over 4, or 0.25. So my scale factor here is 1/4. Haha, just kidding. I promise I can math. It's not a fourth, Miss Kimmy's is silly. It's a half, which is 0.5. Probably like, wait a minute, but 2 times 4 gives me 4, not 2 times 4 gives 2 times 2 gives me 4, but 2 times 4 gives me 8. Sorry about that, guys. Scale factor is 1/2. I divided the top, and I forgot to divide the bottom. Hey, don't let that happen to you. Alright, so let's take a look at some real-world applications. So, some people like to do model cars, because, you know, cars are cool. And they want to figure out, based on the scale factor, what the actual factor of the car is. So, if it's telling me that the model car is 7.6 centimeters, grab a calculator, we're done for them. Told all of you to get your calculator, and I completely forgot I didn't have mine on me. So, calculator. If the model car is 7.6 centimeters, it also tells me that my scale is 1 to 63. That means 1 meter no, yeah, 1 meter is equal to 63 inches, or 63 centimeters. So, what's the length of my actual car? Well, to enlarge it, or to make it bigger to try and figure out what it is, I'm going to use a scale factor of 63. So I'm going to take 7.6, and I'm going to multiply that by 63. And your calculators. So that gives me 478.8 centimeters. Okay, so now I have it all in centimeters, but do I talk about cars in centimeters, or do I talk about it in meters? Think about it this way. Do I want to talk about your height in inches, or do I want to talk about your height in feet? Exactly. We want to convert to the bigger one. So we need to figure out how many centimeters are in a meter. Scroll down a little bit so I have room to write. So think of the word centi and the word century. Century kind of has the centi beginning. So how many years are in a century? 100. So how many centimeters are in a meter? 100. Good. So if I have 478.8 centimeters, I want to divide that by 100 centimeters in order to get the number of meters that I have. Which means I have my car being 4.78 meters. Alright, next one. The height of a tractor trailer is 4.2 meters. Find the scale factor for a model of the truck that is 1 to 54. Find the height of, the scale factor is that. Find the height of the model to the nearest centimeter. So in this case, we're going big to small. So we're going to shrink it down. So to reduce it, we're going to first convert 4.2 meters into centimeters, because it's giving me into centimeters, because it tells me centimeters right here. So 4.2 meters Now I'm going to multiply or am I going to divide? Think about it. If I divide, dividing makes numbers smaller. If I multiply, it makes them bigger. Meters, yes, are larger, but deal with smaller numbers. So I want to deal with bigger numbers. So I'm going to multiply. Yes, you're correct. So I'm going to multiply this first by 100. And that gives me 420 centimeters. Then I'm going to take that 420 and divide it by 54, which is my scale factor. And that gives me 7.78 centimeters. All right, now we're going to go ahead and actually graph our own dilation. So to dilate a triangle or any polygon, we're going to find the dilation of its vertices. So I'm originally given this triangle of P at 2, 0, Z at -1, 1/2, and G at 1, -2. So mine is on the next slide, so I'm going to have to flip a couple slides. You can go ahead and just graph it as you see it. So P's at 2, 0. And when I do these, I'm going to label all of my spots. So P's there. Z is at -1, 1/2. So -1 up about 1/2. And then G is 1, -2. Connect all of my dots together to a semi-pore triangle. So I'm going to dilate that with a scale factor of 3, which means, am I going to get bigger or smaller? Bigger, good. I'm going to go ahead and take all of my, oops, there you go. Sorry, you couldn't see that part. Scale factor of 3. So I'm going to go ahead and take all of my original points and multiply them by 3. So I took my 2, 0, and I multiplied by 3. 2 times 3 gives me 6. 0 times 0 gives me 0. 1 times 3, excuse me, -1 times -3 gives me -3. 1/2 times 3 gives me 3.5, or 1.5. And then -1, -2 gives me 3, -6. So it means I took every single piece and multiplied it by 3. So let's go ahead and plot our new dilations. So P's at -6, 0. Wait a minute, there's 6, 0. 6, 0. So I'm at 6, 0. So 1, 2, 3, 4, 5, 6. Now this is P prime, so I need to indicate it as such. So that's why I need to put those tick marks on there. Z is at -3, 1.5. So 1, 2, 3, 1.5. Oops, I didn't want that first dot there. So that is at Z prime. Then G is at 3, -6. So I do 3, -6, 1, 2, 3, 6. And then again, I go ahead and connect my dots as best as I can. Straight as lines as I can. Obviously, some of these are not the greatest. I'm trying to do this on my computer. You have a little bit more stability drawing with your pencil. So there's my dilated image. So here's my pre-image in red, and my dilation image is in blue. So now what we're going to do is we're going to go ahead and find some of our own vertices, but we're not going to plot them because if you notice we don't have any more graphs, which is okay. We're just going to find them together. So we're going to do the same triangle again, only we're going to dilate this time the scale factor of 1/2, which remember 1/2 is equal to 0.5. So now we're going to take everything times 0.5. So P prime is going to be at 1, 0. C prime will be at -1/2, 1/4. Nope, just kidding. Oh, wait. Okay. And then G prime, excuse me, is at 0.5, -1. Okay, this next one, we're going to have the same, we're going to have different pieces, excuse me, and we're going to dilate it by 0.75, which means we're going to take everything times 0.75. So -2 times 0.75 gives me -1.5. So A prime is at -1.5, comma. Can I hit the right buttons today? -2.25. B prime will be at 0, 3. And C prime will be at 4.5, comma, -9. Okay, so I think that's all we got. Yep. See you tomorrow.